Welcome to this instructional video on using the core features of the Synthesis Explorer online tutorial system. By the end of this session, you should become familiar with all of the basics you need for working on reaction, synthesis, and mechanism problems, as well as tracking your progress records. The first thing to get started is to direct your web browser to the website. Officially, the site supports the Internet Explorer and Firefox web browsers. Although other web browsers like Apple Safari may work, they're known to have some issues, so you'd be better off just using Internet Explorer or Firefox. Once you're ready, direct your web browser to synthesisexplorer.org to be redirected to the website. From there, you should be presented with a primary setup page for the system, showing the main sections on the left and various information notes and announcements on the right. One important section to note is the link to the help and walkthrough pages, which have more detail on using the different pages, though you should get most of the basics from this video. The first major section that will be useful to you is the reaction drills section, where you can work on simple reaction completion problems similar to practicing with flashcards. Clicking on the reaction drills link brings you to this setup box. To prepare some reactions to review, just fill in this box from top to bottom. You may also note on the right is a context-sensitive help box. As you mouse over different fields, the help box will explain what they are for. For example, let's take a look at some basic reactions from the alcohol substitution chapter and do some product prediction problems. Click on Generate Problems and the system will prepare a series of reactions, but with a big blank in each reaction. Your job then is to figure out what should be in this blank. For example, what product would come from reacting this alcohol with sodium hydride? You can work it out in your head or on a piece of paper, and when you're ready, just click on Show Answer so you can check whether you guessed correctly. You get the answer for free because these reaction drills are not actually graded for credit. It's just for your own practice and benefit as a light way to start learning the material before you get into the really difficult synthesis problems, although it also does happen to be the most common style of exam question. To really learn the material, though, you need to know your reactions forwards, backwards, and sideways. What I mean by that is that you shouldn't just do product prediction problems. You should be able to predict any missing component in the reaction. Here again is a series of reactions, but this time the blank can be anywhere. So now instead you may see that something, when treated with HBr, produces this molecule. So what was that something? Or something, when applied to this alcohol, produces this molecule. So what was that something? If you really wanted to, you could also just say, I don't want to predict anything. In this case, the system will just present you with a list of reactions with everything shown, which is perfect for printing out the page so you can keep it as a review sheet summarizing the major reactions for each chapter. Once you've gotten comfortable with the basic reactions in a chapter, you're ready to move on to an actual multi-step synthesis problem, which is where most of the action is. To prepare a synthesis problem, just go to the Synthesis Explorer section and fill in the setup box from top to bottom. To have the system keep track of your progress, you'll have to log in by entering your student ID number here. And make sure it's your ID number, as that is what your instructor uses to record your grades. From there, select which class you belong to, and for now, let's work on a random synthesis problem. To do that, we'll just leave this selection as Generate Random Synthesis, and then select which chapters of material we're interested in working on. For example, let's try a problem based on the alcohols and epoxides chapter, and which requires no more than 2 steps to solve. Click on Generate Problem, and then the system will prepare a synthesis problem based on the selections we just made. Here we have the primary synthesis problem interface for the system. What we are presented with is a target product that we, as students, are supposed to try and make somehow. And what we have available to us is a list of possible starting material reactants, as well as a list of reagents, the kinds of things that, presumably, we've been learning about in class or from the textbook. Our job, then, is to piece together the correct combination and sequence of reactants and reagents to reproduce this target product. One of the first things I'd go ahead and do for any problem is to click on this hint button, which narrows down the list of possible starting materials. The hint is free, so you might as well take it. And once you've taken it, look for this black line. You should only need the reactants listed above the line to solve the problem. You don't have to use any of these reactants, it just means you should not need anything else. Now let's actually try to solve this problem. Looking at the product, I'm thinking a Williamson ether synthesis by an SN2 substitution. However, looking at our available reactants, none of them has a decent leaving group to facilitate such a substitution. So the first thing we're going to need to do is to convert one of these alcohols into a good leaving group. To do that, just click on a reactant you want to work with to copy it to the pathway workspace area below. Then click on a reagent you want to work with, such as this thionyl chloride and pyridine, to copy it to the workspace. Now that we have both a reactant and a reagent selected, click on the big Apply Reaction to Generate Products button, and the system will actually predict the major product of that reaction, which is this alkyl halide. To continue the synthesis, click on the product of the reaction to copy it as a reactant for a new reaction step. To finish the synthesis, we just need to do an SN2 substitution with this alkyl halide, which we can do by adding in a good nucleophile like this ethoxide ion. Notice how you can have more than one molecule on the reactant side of the equation to represent mixing chemicals together. In this case, there is no particular reagent to apply since it's really a reactant-driven reaction. So instead, just select one of the reagents which says something like mixed reactants or catalyst. Apply reaction to generate product again, and this time, since the predicted product matches the target product, the system congratulates us for successfully solving the problem. When you do this, make sure that you see this line. Your progress was successfully recorded in the system, so you know that the system is actually giving you credit for your work. Once you have completed a problem and want to work on another one, just click on New Problem, and the system will make up another target product based on the same chapters of material. Once it loads, you can still get a hint for the new problem, and if you ever get completely stuck on a problem, you can always access the expected solution. It's warning us that you will no longer be able to receive credit for solving the problem once you have seen the solution, but don't let that discourage you. The real point of this system is to help you learn the material, so go ahead and look at the solution for a couple of problems, then hopefully after that you'll know how to solve the next set of problems on your own. When you want to work on something else, click on the Return to Setup link to get back to the initial setup page, and from here you can prepare another synthesis problem based on different chapters of material. In fact, you can even select combinations of multiple chapters and problems of greater length to generate even more difficult problems that will really challenge your knowledge and better represent the difficulty of real exam problems. So far we've been talking about how to generate random synthesis problems, but your instructor will also assign you several specific non-random problems. To access these, just go to the same synthesis problem setup box, but instead of selecting Generate Random Problem in the synthesis problem list, select one of the specific problems listed. When you select one of these problems, note how it selects the chapters and steps for you, because these are not random problems. They have been pre-constructed and specifically approved by your instructor as an important and relevant material. Otherwise though, just click on Generate Problem and the setup is exactly the same. You still have a target product to make, but this time it is not a random product. Every student who works on this problem will get the same target product to work on. You can still get a hint for free, but now the solution for the assigned problems are locked until you've actually solved them. You're likely to find that many of these assigned problems are actually pretty difficult, but don't feel bad about it. They are specifically designed to be challenging, so just keep on trying. An important point to note is that with every problem in the system, you have unlimited tries to solve the problem. There is no time limit to solve the problem other than the assignment due dates, and there is no penalty for guessing, so just go wild. Feel free to experiment with the problems without worry, because you can never do anything wrong in the system. As an extra hint for solving these assigned problems, take a look at the problem description as it includes references to chapter sections from the textbook. These refer to the last chapter section you need to understand in order to solve the problem. This also means that if you just read that section of the textbook, it's probably a huge hint towards solving the problem. There are many non-random problems to choose from, but when you select which class you're in, the list will be filtered down to just those assigned by your instructor. However, you're still free to work on the other non-random problems, and they will still count towards your total problems completed and would be very good practice.